Okay, let us do this problem. So this is from gravitation. So let me read the problem first, and then you understand the problem, and then you try yourself, and then you see the solution. So this time you have to listen carefully the problem, and then you have to attempt. I will give you time. So the problem says a planet of mass m moves along a circle around the sun with velocity v, that is 34.9 km per second. So what is given? So I have this sun, and there is a satellite of mass m, sun of having mass ms. So this satellite is moving in a circular orbit. So this is moving in a circular orbit, something like this, around the sun, and velocity is also given, that is 34.9 km per second. So this is the first part. Find the period of revolution of this planet around the sun. So what is the time period of this planet around the sun? This means after what time this sun will move one complete circle. So you have to find what will the time that will be required to move in one complete circle. So what you have to do is, you have to write two equations, basically one equation. Force is equals to mass into acceleration towards the center, and then you have to find time period. Time period is 2 pi r by v. So that is enough hint. So you have to find time period, that is 2 pi r by v, and v you will find writing the equation of motion in a circle. So let us make a stop in your computer and then work. Let us do for 3 minutes. So let us make a pause on your computer and take 2 minutes to 3 minutes time. Okay, so most of you have done this one. This one is a pretty easy problem. So let us now see the solution. So what this solution says, you see, so force in gravitation, we know the total force acting is gmm by r square with a minus sign. Minus sign says this force is attractive in nature. So this means on this mass m there is a force that is acting towards the sun, and this force has a magnitude of gmm by r square. If now something is moving in a circle, I know total force towards the center is equals to mass of object, that is m, into acceleration. I know acceleration is v square by r. So this is force is equals to mass into acceleration. So from here I can calculate v square, mm cancels out, so v is gms by r. So let us call this equation as equation 1. Everybody knows that v is gm by r. Sometimes this is called orbital velocity. Some people directly remember this result. So what is this result is? So they remember something like this. Orbital velocity is under root gm by r. So if satellite is moving in a radius of r, orbital velocity is given by under root gm by r. So either you derive this result or you simply remember that is orbital velocity is under root gm by r. Now if you know orbital velocity, in this case this is moving around the sun, so this mass of sun will come. If this is moving around the earth, the mass of earth will come. This is not the mass of planet. This means time period or velocity of a satellite is independent from its mass in a circle. If it is moving in a circle, in that case it is independent from the mass of the object, mass of the planet in this case. Now what is the time period? So time period we will have, that is 2 pi r by v. So you see what is the total distance. If you have a circle, the total distance is 2 pi r. In a circle, this total distance is 2 pi r, and the linear velocity is v, so 2 pi r by v. You have found the same result even if you have used 2 pi by omega, because 2 pi is the angle and angular velocity is omega, but v is equals to r omega, so 2 pi by omega is nothing but v by r. So you have got the same result, that is 2 pi r by v. So now 2 pi r by v I know from the first part, that is under root gms by r. If I plug this value, this come out to be 2 pi r to the power 3 by 2 divided by under root gms. Now you know, and in this question r is not given, but v I know. So b is given, r is not given. So I can, from the equation 1, I can find r, eliminating r, and can find r in terms of v. So if I see equation 1, so v square, if I square this one becomes gms by r, so from here I can find gms by b square. And now if I plug the value of r here, so in this equation, if I plug this value of r, so this becomes r to the power 3 by 2 I need. So r to the power 3 by 2, this becomes gms into under root gms by b square. So 3 by 2, so b square into 3 by 2, this becomes bq. If you plug this value of r to the power 3 by 2 here, so r to the power 3 by 2, I have r to the power 3 by this value. So if I plug this value r to the power 3 by 2, so gms cancels out. Are you getting or not? Gms and under root gms cancels out. So finally you have 2 pi gms by bq. Now what you have to do is you make a pause on your computer if you have not written anything, if you have missed. So let us write and then make a pause and you write. We will go for the next problem.